How long is a day? That's not a trick question. You'd say 24 hours. Everyone says 24 hours.
I would have said it too, until I looked at the numbers kept by the people whose actual job is to time the planet. Because no day in your entire life has been exactly 24 hours long. And since 2020, something stranger has been happening. The days have been getting shorter, and nobody can fully explain why. For most of human history, the Earth was the clock. The day defined the hour defined the second. Then, in 1967, we rebuilt the second on something steadier than the sky. An atom. 1 second became 9,192,631,770 vibrations of a cesium atom, frozen forever. And from that moment, the planet had a rival. An atomic clock drifts about 1 second every 100 million years. The Earth, measured against it, turned out to be a sloppy clock. Every single day, a slightly different length, nudged by winds, tides, earthquakes, and the molten machinery underneath us. I assumed the wobble just averaged out. It doesn't. It drifts. And for decades, the drift ran in exactly one direction: slow. That made perfect sense. The moon is breaking us. Every tide it drags across the planet steals a little rotational energy, and the day stretches by about 2 milliseconds per century. Run the tape backwards and you can check it. A fossil clam from the age of the dinosaurs grew daily growth rings, and it recorded 372 days in a year. The dinosaurs lived a 23.5-hour day. Go back far enough and a day was 19 hours. Slowing down isn't a phase, it's a 4 billion year trend. Around 2020, the trend broke. The Earth sped up. That 1 year logged the 28 shortest days ever measured in the atomic era. Then the records just kept falling until July 10th, 2025, the shortest day ever recorded, 1.37 milliseconds short. That sounds like nothing. The clocks noticed. So what's spinning us up? I assumed it had to be something on the surface, and the obvious suspect is melting ice. Except melting ice does the opposite. Meltwater from Greenland and Antarctica flows away from the poles and settles toward the equator, mass moving outward like a spinning skater opening her arms. That slows us down. The acceleration is coming from somewhere we cannot see. The best suspect is 3,000 kilometers beneath your feet. The Earth's liquid outer core appears to have been slowing down for about 50 years, and angular momentum has to go somewhere. If the core spins down, the rocky shell we live on spins up. We can't observe it directly. We can't predict it. We found out because the length of the day told us. And here's the part I didn't expect. That meltwater, the climate signal, has been quietly masking the core's speed up. One geophysicist ran the numbers in Nature. Without global warming, our clocks would have hit crisis around 2026. Instead, around 2029. Melting ice caps bought the world's timekeepers 3 extra years. Crisis? Meaning what exactly? Since 1972, whenever Earth fell behind the atoms, we added a leap second. 27 times! Even adding 1 breaks things. The 2012 leap second took down Reddit and crashed an airline's check-in system worldwide. A fast Earth demands the reverse, a negative leap second. A minute with 59 seconds in it. It has never been attempted. The odds we need one within a decade? About 40%. Google won't even play along anymore. It secretly smears the leap second across a whole day. GPS gave up in 1980. Its clocks now run 18 seconds ahead of yours. So this October, the world's measurement authorities vote on the retreat. Retire the leap second and let the sky and the clock drift apart, maybe for centuries. Which means time is not something we measure, it's something we negotiate. Midnight is a committee decision, a treaty between the sky and the atom, and the treaty is being rewritten because the planet stopped holding up its end. So, how long is a day? The honest answer is ask again tomorrow. Even the Earth doesn't know.